the function takes as parameters like the client TCP port. So let's say TCP port is 8983. So the function of 8983 will return 2. This server will also calculate it, 8983, and it will get 2. And this one, 8983, and this will get 2 because this is the exact same function that is executed against the same IP packet. So the server W1 knows is not concerned because 2 does not equal 1, so it will drop the packet. Server 3 will do the same because 2 is different than 3, and this one will process the packet. So the mechanism is quite simple. It's done at the low level in the stack of Windows. An important thing to understand is that it doesn't depend on how the HTTP works. The HTTP application works. If the HTTP application does not work, but Windows still works, then the request will go to the server. So in order to have high availability at application level, it's important to have some monitoring going on that will work that way. So monitoring will watch the 3 servers by issuing HTTP GET here, here, and here. And if one server does not respond, it will be moved out of the farm by reconfiguring the farm on the 3 servers, because this one is so up at the Windows level. But if it's not, then it's already out of web farm. If it is still in the farm, then this one will be removed and the others will be notified. So the web first, and the function will only give this station or this station as a station that could take the requests. So even if it goes here, one will process the request, the HTTP application doesn't work. And another reason is that as it was moved out of the it won't have the virtual IP address in its IP stack, so it won't get the packet. The 2 remaining servers will apply the function, but the function will only tell this station that must process the request. So let's compare the 2 solutions. On the other side, we have some monitoring at hardware level. On the Windows network load balancing, we'll have some monitoring at with a MOM solution or another solution, or SCOM. System Center Operations Manager, or any other monitoring solution. So this is done here, and the monitoring is done by hardware. At the hardware level, we need some equipment, which is the hardware itself, and it must be redundant, so that you don't have a single point of failure. At this level, you just have to configure the switches. Another important difference is that client and web farm must be in different VLANs, because the hardware is a kind of router. In this one, in this solution, client and web farm may be in the same VLAN or a different one. So in a scenario where you have let's say, I don't need this one. In a scenario where you have let's say the clients, then a VLAN for the data center, where you have some of your servers and you have a first farm. Let's say it's a Beanstalk farm, for instance, or it can be a web farm, and then you need to access another farm, which can be a web services farm. So let's say a web farm and a web services farm. Between here and here, you might be in the same VLAN. So this VLAN may be the same for here and here. In this case, Windows Network Load Balancing is a good option, because you don't need to route to go through a gateway, through a router between the two. So thank you for listening.